We often admire massive buildings, bridges, and dams. But behind every one of these structures, there's more than engineering and blueprints. There's heavy machinery. Roads, embankments, drainage systems, and industrial zones simply wouldn't exist without powerful machines that move, cut, lift, and shape thousands of tons of material every day. Watching an empty site turn into a finished project is fascinating, but it becomes even more interesting when you understand what each machine does and why it appears on site at a specific moment. Today, we'll break down construction machinery in a logical, real-world order, the same way a site actually comes together. Let's start at the beginning. Bulldozer, preparing the ground. Almost every construction project begins with a bulldozer. Its role is not precision, but raw power. Bulldozers clear vegetation, remove topsoil, and roughly level the surface, creating the first workable area for other machines. Tracked undercarriages provide excellent traction and stability, even on loose soil and uneven terrain. Without this step, bringing in heavier or more precise equipment would be impossible. Excavator, the core of earthworks. Once the site is prepared, the excavator takes over. This is the primary machine for digging foundations, basements, and deep pits. A single bucket scoop can move as much material as a person would in an entire day, often much more. With different attachments, excavators can also lift heavy objects, break rock and concrete, or even perform crane-like tasks. On most projects, the excavator becomes the central machine around which everything else operates. Trencher, utilities first. Before concrete is poured or surfaces are finished, underground systems must be installed. That's where trenchers come in. Their job is to dig long, narrow, and consistent trenches for pipes, cables, and drainage systems. Many use a rotating toothed chain that works like a giant chainsaw for the ground. This stage ensures water, electricity, communication, and sewage lines are placed correctly before the site is closed and compacted. Backhoe loader. Not every task requires large, specialized machines. The backhoe loader combines a front loader and a rear excavator in one unit. It's ideal for smaller sites, utility work, and fine adjustments where larger machines would be inefficient. One machine, multiple roles, especially valuable when space and resources are limited. Wheel loader, moving material on site. Once material has been excavated, it needs to be moved. Wheel loaders are built for fast transport of soil, gravel, and stone across the site. Their large front buckets and articulated frames allow them to maneuver easily, even with a full load. They form the backbone of on-site material handling, keeping work moving efficiently. Skid steer loader. As construction progresses, space becomes more limited. Skid steer loaders are compact, highly maneuverable machines designed for tight areas. Their strength lies in versatility. With the right attachments, they can lift, drill, sweep, or break material. On crowded or urban sites, skid steers often handle tasks that larger machines simply can't reach. Dump truck, moving material off-site. When material needs to travel longer distances, dump trucks take over. They haul excavated soil away and deliver sand, gravel, and other materials back to the site. Hydraulic systems raise the dump body to unload material efficiently. Because of the heavy loads involved, many dump trucks use additional axles to distribute weight and meet road regulations. Scraper, built for massive earth moving. On large-scale projects like highways, dams, and major embankments, a different approach is often used. Scrapers cut material directly from the ground, store it in an onboard bowl, transport it across the site, and unload it using a hydraulic ejector. While not used everywhere, scrapers are extremely efficient when huge volumes of earth must be moved quickly over long distances. If you're interested in how heavy machinery actually works, not just watching it, but understanding it, subscribe to the channel. New videos like this are coming regularly. And now, let's move on to road construction machinery. Although a motor grader is technically classified as earth-moving equipment, it is most commonly used in road construction. Its long wheelbase and centrally mounted blade make it ideal for precise surface leveling. The grader removes small irregularities and forms the final road profile, including slope and drainage angles. Any mistake at this stage will affect every layer that follows. Road rollers, compacting the base. Once the base material is shaped, it must be compacted to prevent future settling. This task is handled by road rollers. Different types are used depending on the material. Smooth drum rollers for asphalt and granular soils. Padfoot and sheep's foot rollers for clay and cohesive soils. pneumatic tire rollers to seal the surface and improve uniform density. Many modern rollers use vibration, helping the material settle more evenly. Proper compaction is critical for long-term durability. Asphalt paver, where a road becomes a road. This is the moment when a road truly becomes a road. Hot asphalt is delivered to the asphalt paver, which spreads the mixture evenly over the prepared base. A heated screed at the rear levels the asphalt and sets the initial thickness. Modern pavers often use string lines or automated leveling systems to maintain precise height and slope, ensuring the surface meets engineering specifications. Concrete roads, slip-form concrete pavers. When a road is built from concrete instead of asphalt, a different process is used. The slip-form concrete paver continuously shapes the roadway, curbs, or barriers without traditional molds. Thanks to precise control of the concrete mix, the pavement exits the machine fully formed, with accurate geometry and smooth edges. Cold milling machines, removing old pavement. Road surfaces cannot be resurfaced endlessly. If new asphalt were constantly placed over old layers, the road would gradually rise. To prevent this, the worn surface is removed first using a cold milling machine. A large rotating drum cuts away the upper layer, while a conveyor transfers the removed material directly into a dump truck moving alongside, keeping the operation continuous and efficient. The paving train, machines working as one. Road construction is a coordinated process. A typical paving train includes dump trucks delivering hot asphalt, an asphalt paver placing the material, and one or more rollers compacting the surface to the required density. Throughout the process, ground crews monitor temperature, thickness, and surface quality to ensure the road is smooth, uniform, and built to specification. And if any of you watching operate one of these machines, share your experience in the comments. Now let's move lower, literally beneath the surface, and talk about foundation machinery. Large and heavy structures cannot rely on surface soil alone. Skyscrapers, bridges, and industrial facilities must transfer their load to strong geological layers deep underground. When the soil near the surface is weak, this load is carried downward using piles. Piling rigs, drilled piles. One common method of pile installation is drilling. In this process, a deep vertical hole is drilled into the ground. A reinforced steel cage is placed inside, and the hole is filled with concrete. The result is a strong structural element capable of carrying enormous loads. This work is performed by pile drilling rigs. In size and design, many of these machines resemble oil and gas drilling rigs. They are built for depth, precision, and stability, often operating under extreme loads. Drilled piles are widely used in high-rise buildings, bridges, and large infrastructure projects. Pile drivers, driven piles. Another approach is to drive piles directly into the ground. This method uses a pile driving rig that repeatedly strikes the pile, forcing it deeper into the soil. Depending on the project, piles can be made of wood, steel, or reinforced concrete. Pile driving is loud and generates strong vibrations, but it is fast and highly effective. In suitable soil conditions, it provides excellent load-bearing capacity and long-term stability. Horizontal directional drilling, utilities without trenches. In dense urban environments, traditional trench excavation is often impossible. Digging up streets, railways, or developed areas can severely disrupt traffic and infrastructure. In such cases, horizontal directional drilling, HDD rigs allow pipes and conduits to be installed underground without disturbing the surface. The drilling head is precisely guided, making it possible to pass beneath roads, rivers, and buildings while maintaining accurate alignment. This technology is essential for modern cities, where space above ground is limited, but underground networks continue to expand. Water well drilling rigs, accessing groundwater. There is another type of drilling machine working deep below the surface, often far from construction sites. Water well drilling rigs are used to reach underground aquifers and bring clean water to the surface. These machines drill deep vertical wells through soil and rock layers until groundwater is reached. They are commonly used in rural areas, agriculture, remote industrial sites, and regions without centralized water supply. While simpler in appearance than piling rigs, water well drills play a critical role in providing one of the most essential resources: water. Everything built above ground depends on what happens below it. Foundations are invisible once construction is complete, but they carry the entire weight of the structure for decades. Without specialized foundation and drilling machinery, modern cities simply could not exist. Once the ground has been prepared, and the foundation work is complete, construction does not stop. It simply moves upward. At this stage, massive elements must be transported, lifted, and positioned with precision. Beams, concrete slabs, steel structures, and large pipes all need to be handled safely and accurately. This is where lifting and handling machinery comes into play. First and foremost, cranes. Pipe layers. One specialized machine used at this stage is the pipe layer. Pipe layers are designed specifically to handle large pipe sections. They allow operators to lower pipes into trenches and position them with high precision. This is critical for pipelines carrying water, gas, or industrial materials, where even small alignment errors can affect safety and performance. Telehandlers. Another essential machine is the telescopic handler, often called a telehandler. It is an off-road loader equipped with a telescopic boom. Depending on the task, the boom can be fitted with pallet forks, a bucket, or a winch. The telescopic design allows materials and equipment to be placed exactly where they are needed, both in height and horizontal reach. Telehandlers are widely used for material handling, equipment placement, and general support work across construction sites. Aerial platforms. When the task involves lifting people rather than materials, different equipment is used. Aerial work platforms, including boom lifts and scissor lifts, allow operators to work at height while standing on a controlled platform. This provides far greater precision and safety than ladders or temporary scaffolding. Bucket trucks, commonly used for electrical and utility work, also belong to this category. They are often seen during maintenance of power lines, street lighting, and communication infrastructure. All-terrain cranes. As construction progresses, loads become larger and heavier. This is where all-terrain cranes come into play. If you have ever seen a massive crane driving on a public road, it was most likely one of these. Unlike many crane types that must be transported in sections and assembled on site, all-terrain cranes are designed to travel independently on public roads. Once on site, they can operate on rough and uneven terrain, combining mobility with significant lifting capacity. Crawler cranes. For even heavier lifting, crawler cranes are used. Mounted on tracks instead of wheels, crawler cranes are slower and more massive than wheeled cranes. Because of their size, they are typically transported in sections and assembled at the job site. In return, they offer exceptional stability and lifting capacity. Their configuration can be adjusted by changing boom length, adding counterweights, or installing additional jib sections. In some cases, crawler cranes are even used for demolition, lifting heavy wrecking tools and dismantling large structures. An impressive sight, to say the least. Tower cranes, building upward. Not all cranes move across the construction site. The tower crane is a stationary lifting machine with a tall vertical mast, a long horizontal jib, and an operator's cabin positioned high above the ground. Tower cranes are essential for high-rise construction, where materials must be lifted vertically to great heights. Some tower cranes are so large that their installation becomes a construction project of its own, requiring other cranes to assemble them. It is almost impossible to imagine a construction site without concrete. Because of this, an entire class of specialized machinery has been created specifically to work with this material. Concrete mixer trucks, mixing on the move. The most recognizable machine in concrete work is the concrete mixer truck. Dry materials and water are loaded into the rotating drum, and mixing continues while the truck travels to the site. This is critical because concrete has a limited working time before it begins to set. Although the machine looks simple, the internal mixing process is carefully designed to keep the concrete uniform and workable until discharge. Concrete pumps, reaching where trucks can't. In many situations, concrete cannot be poured directly from the truck. This is where concrete pumps are used. They deliver concrete to hard-to-reach locations, often at significant heights, using long booms or pipeline systems. Concrete is more than twice as dense as water, which means these pumps operate under extremely high pressure. Modern pump booms can exceed 100 meters in length, allowing precise placement even on very tall structures. Concrete finishing machines, final surface quality. On small projects, concrete finishing is often done by hand. On large sites, however, walk-behind and ride-on finishing machines are used. These machines level and smooth the surface once the concrete has begun to set, but before it reaches full strength. Proper finishing improves durability, surface quality, and long-term performance. Mobile concrete batching plants. For projects that require large volumes of concrete, Producing it on-site is often more efficient. Mobile concrete batching plants allow concrete to be mixed continuously at the construction site, reducing dependence on mixer truck deliveries. This solution is especially useful on long-term projects or in remote areas where transportation is limited or impractical. Shotcrete equipment, applying concrete under pressure. In some cases, concrete must be applied to vertical or inclined surfaces. This includes stabilizing rock slopes, lining tunnels, or forming complex shapes such as pool shells. These methods are commonly referred to as shotcrete. Shotcrete equipment sprays concrete under high pressure, allowing it to bond strongly to the surface without traditional formwork. This technique is widely used for reinforcement, ground stabilization, and repair work. From foundations and walls to bridges and tunnels, concrete is one of the most important materials in modern construction. Without specialized machinery to mix, transport, pump, and finish it, large-scale construction simply would not be possible. The underground giant, tunnel boring machines. And finally, one of the most impressive machines in construction, a machine that is rarely seen on the surface, the tunnel boring machine, or TBM. This is a massive system that excavates the ground, removes the excavated material, and installs tunnel lining segments at the same time. It is essentially an underground factory on wheels, operating deep below cities, rivers, and mountains. Without tunnel boring machines, modern metro systems, underground highways, and large-scale utility tunnels simply would not exist. Of course, it is impossible to cover all construction machinery in a single video. The industry is incredibly diverse, and for almost every task, there is a specialized machine designed to do that job efficiently and safely. Heavy equipment is also used far beyond construction, in mining, oil and gas, railways, and many other industries. Each of these machines plays a role in shaping the world around us. I want to point out one important thing. I am not a professional builder or equipment designer. I am a blogger who is genuinely fascinated by heavy machinery and by how the world around us is built. If any of you watching work with this equipment or have professional experience you would like to add, please share it in the comments. Your insight can make this video even more valuable for everyone. And to finish, here's a question for you. Out of all the machines we talked about today, which one would you most like to operate, and why? Let me know in the comments.